sklearndecompositionDictionaryLearning. Description dictionary learning is a powerful dimensionality reduction technique in scikit-learn that aims to learn a set of atoms or dictionary elements that can represent the data efficiently. It's particularly useful when dealing with sparse signals or data with complex underlying structures. Inputs. X. This is the input data, usually a NumPy array or similar structure. Each row in X represents a data point, and each column represents a feature. N components. This parameter specifies the number of atoms dictionary elements to learn. It directly controls the dimensionality reduction. Outputs. Components. This is the learned dictionary, a NumPy array where each row represents an atom. These atoms can be interpreted as the fundamental building blocks of your data. Code. This is the sparse representation of your original data using the learned dictionary. Each row in code represents a data point, and each column represents the coefficient of a particular atom in reconstructing the data point. Steps. Initialization. The algorithm starts by randomly initializing the dictionary elements. Iterative optimization. Dictionary learning iteratively refines the dictionary elements and sparse code by minimizing a cost function that encourages sparsity in the representation and accurate reconstruction of the original data. Convergence. The process continues until the dictionary and sparse code converge to a stable solution, meaning the cost function no longer significantly decreases. Metrics. Sparsity. The degree of sparsity in the learned sparse code. This is desirable because it means the data can be represented using only a few non-zero coefficients, indicating a compressed representation. Reconstruction error. This measures how well the original data can be reconstructed from learned dictionary and sparse code. Lower reconstruction error means better data representation. Visualization plots. Dictionary visualization. The learned atoms can be visualized as images, histograms, or other appropriate plots to gain insight into the underlying structures in the data. Sparse code visualization. The sparse code can be visualized as heat maps or scatter plots to understand which atoms are most important for representing different data points. Fine-tune parameters. Alpha. This parameter controls the sparsity of the learned code. Higher values encourage more sparsity. Transform. Non-zero coefs. This parameter influences how many non-zero coefficients are used for representing each data point. It can be helpful for controlling the complexity of the sparse representation. Uncertainty methods. Bootstrapping. Multiple dictionaries can be learned from different subsets of the data. Bootstrapping to assess the variability and uncertainty of the learned atoms. Bayesian methods. Bayesian approaches can be used to incorporate prior knowledge about dictionary and estimate the uncertainty of the learned components. Challenges and fixes. Challenge 1. Data preprocessing. If the data has features with very different scales, it can impact the learning process. Sample use case that resulted in challenge 1. Learning a dictionary from data with features that have vastly different ranges can lead to some features dominating the dictionary learning process. Fixes to challenge 1. Standardize or normalize the data before fitting the dictionary learning model to ensure all features have similar scales. Challenge 2. Choosing n components. Selecting the appropriate number of dictionary elements is crucial. Too few components might not capture the data well, while too many components can lead to overfitting. Sample use case that resulted in challenge 2. Setting n components too low might not represent the underlying structure of the data, while setting it too high might lead to a dictionary that is not generalizable to new data. Fixes to challenge 2. Experiment with different values of n components. Consider cross-validation. and use visualization techniques to assess the quality of the learned dictionaries for different values.